Fuzzy good morning to all of you. Thanks for getting up so early. Yeah, let's talk about VPNs and how to confuse routing tables with them. If you want to tweet me, this is the info you need. And what is a VPN? In simple words, it's a virtual network cable that you can plug into a remote switch over the internet. That's a handy thing to have. So it connects two network segments over some kind of wire. Why would you want to use them? Well, there's multiple use cases for VPNs. It's either you want to access a remote network, like your home network from abroad or the company network from somewhere else, or you want to protect your own traffic from prying eyes, like a cafe that offers free Wi-Fi, but they not only sell coffee, but they also sell your data by checking where are you surfing to. Or GSM carriers, handy carriers, they are very well known for manipulate traffic, inject ads and cookies and tracking stuff into websites. You want to protect yourself from those for websites that don't offer HTTPS and protection with that one. A VPN will never provide you with anonymity. I know many vendors say, well, you're anonymous with this VPN. You're not. The VPN vendor knows who you are, and they can correlate all that traffic. So that's usually a blunt lie. But it will give you some privacy in dependence of what is your threat model. So VPN solutions, there's a ton of them available. Some are open source, some are proprietary and commercial. Some are gratis and free, some are for pay. There's hardware and software-based implementations. And pretty much none of them work everywhere. So depending on what devices you want to use, you have to mix and match and see what you can get going. And if you're getting some hardware solutions, like those privacy boxes that are spawning everywhere in the last few years, maybe you want to check if the privacy that's on the label is actually in the box as well. So let's have a look at some of the solutions. VPNs use a protocol usually, and there's a bunch of them, and some are bad and some are worse. The all well-known PPTP, the point-to-point tunneling protocols by Microsoft, 1999. It's pretty ancient now. It's fundamentally broken by now and has been for many years. Crypto is optional. It's usually 40-bit ciphers. Some offer 128-bit ciphers, but still there's cloud cracking services where you insert a PCAP and $200 and you get the plaintext traffic back. And they're just throwing some Amazon cloud instances at it and just crack it. Yeah, authentication is done via MS-CHAP, Microsoft Challenge protocol. It's also fundamentally broken in version 1. And even Microsoft themselves have been saying, don't use it anymore for over 5 years now. So please, if somebody offers you a PPTP VPN, it's really only to confuse routing tables. It will not provide you anything else but problems and insecurity. Just don't refuse them. Then there's the layer 2 tunneling protocol. It's often combined with IPsec since it's a combination of PPTP and a Cisco layer 2 forwarding protocol. It's specified in an RC from 1999. If you follow the top hits and music charts, that was Mambo number 5 with Lou Bega that year. So that might be a reason why not to use it. It uses IKE, the Internet Key Exchange Protocol, to establish a tunnel and authenticate, but it does not bring these things by itself. It does not bring any encryption, so it's combined with IPsec. Which means you not only need 2 UDP ports to open on your firewall, you also need a protocol ESP, which is on the same level as TCP and UDP. ESP is protocol 50, the other ones are 17 and 6. And many routers, especially cheap ones by your internet provider, these plastic boxes that give you Wi-Fi at home, they don't cope well with that usually. So it's a cumbersome thing. You don't want to use it. The security has been broken. Even if you use it with certificates, it's incredibly annoying. Then there's pure IPsec. That sounds nice. It comes in multiple modes, and some of them are more broken than others. It does a lot of expensive crypto operations before actually your connection has been established. So they're really easy to DOS, so you can just keep them handshaking forever without ever getting a connection. And the so-called aggressive mode of IPsec VPNs sends a hash of your pre-shared key, which protects your traffic, in the clear. So if you can throw some CPU cycles at it, you can do offline dictionary attacks at any speed you can afford. So yeah, there's better solutions. Let's find some better ones. OpenVPN, the community edition, there's also a commercial one that nobody uses or nobody knows about. It can be made reasonably secure. It's some work. We'll see how that goes. In 2017, earlier this year, there have been 2 independent security audits of the OpenVPN code source base, which is a good thing. I don't know why they did not team up in an effort. They pretty much found mostly the same problems with the code. These have all been fixed by now. It's a very good thing. And then some guy came along and said, well, I adapted the code, I injected a fuzzer, and I found these things, which the other 2 audits did not find at all. But he really went into great effort to actually do this, so there's nothing to complain about that the audits did not find this. But he also helped improve the software, which is great. And we're currently on OpenVPN 2.4.3. You really do not want to use anything older anymore. Even if you're forced to do is refuse it, update, please. For your own safety, do this. Some benefits of OpenVPN: it can be run purely on a single UDP port, which has better performance. It can be purely run on a single TCP port, which is a little less performance, but you can route it over Tor, for example, which can only do TCP. And the drawbacks are many operating systems require you to install a separate client or server. It does not come out of the box. Even most Linux distros, you must install something afterwards. For the really nice but somewhat scary things, IPsec with IKv2, Internet Key Exchange version 2. It's basically a rework of the original IPsec IKv1. It loses a lot less RFCs, it's more modern crypto, it's less vulnerable to spoofed connections, it doesn't do any hard crypto before establishing a connection, all that comes later. So it's not that easy to DOS, and most operating systems come with support for it out of the box. So there's nothing you need to install on your device or operating system, really. Any Linux, BSD, Macs, Windows, they come with this. So that's a convenient thing to have. And also the performance is a lot better than before. It offers session resumption, which means when your connection drops, it automatically reconnects and does that very efficiently. And it even works on phones, and that's very efficient there as well. So that's a nice thing. So why not just get a VPN provider? There's a ton on the market. Just insert some coins and be happy. My traffic's protected. I can use it whenever I like. I don't have any work to do. Well, did you actually look at the implementations of commercial VPN providers and how secure they actually are? I mean, they claim bells and whistles on their websites, of course. Somebody did. A person's called That Privacy Guy. Literally, That Privacy, that's his nickname. And he has thatoneprivacysite.net, where you can look up all the information. It's a colorful piece. You see there's not a lot of green in there. If you actually sort by security, it's pretty much 2 pages of red. And he really, really, really looked into detail. So this is not all of the data he collects. This is, I mean, it's a 2-point font. Nobody can read this, of course. It's a huge sheet. It's available as an open document sheet for LibreOffice and Excel. You can look up every bit they tested and looked at, including business ethics and all that stuff, and plain security config. This thing is huge, and it's really helpful. For example, you find things like these. These are pre-shared keys. They protect the traffic you encrypt. And why are they here? On the left-hand side, the black letters, these are VPN providers. They take money for protecting your traffic, or at least claiming so. On the right-hand side, you have the plaintext passphrases they use to encrypt your traffic. They're on the website, and they're the same for every customer. So you can pretty much, if you can sniff the traffic, you can decrypt it. This is not what I expect from a VPN provider I insert coins to. So it's a little hard to trust some of them. Solution? Well, host it yourself. Yeah, OpenVPN's kind of scary, and IPsec even more so. How would I go? What would I need, actually? Well, actually, the requirements are simple. You get a virtual machine somewhere, or a VPS, you host from a hosting provider for a few bucks. A gigabyte of RAM and a single core is way more than enough. 10 gigabyte storage, nobody needs that. You get by with half a gigabyte by far. And you can get a VM with that specs for €5 or $5. So that's like, I don't know, 600 dinar, something, maybe a little more. So that's pretty affordable, actually. Or if you run your own hardware, so like my first VPN server, you can do that. It doesn't need a lot. You can get a small embedded board or an old PC or even a Raspberry Pi or some ARM single board computer is fine. As for software, yeah, you can just get a virtual machine or some jail somewhere. Or maybe you have a spare box that has too many CPU cycles to idle and you want to make good use of them. So what can we install on software here? Let's look at OpenVPN. You will be using the community edition because it's free. It uses TLS, so the Transport Layer Security Protocol we're all familiar from email and HTTPS websites. It uses a username and a password and can be configured with client certificates. It's the only way to be secure with client certificates. Certificates, of course, mean a lot of overhead to work, and this scares people off, but you can do this. It depends on OpenSSL as the default crypto library, which can be a bit scary in itself. You can link it against LibreSSL if you're so inclined. That works fine, gives a little more confidence. And yeah, let's look at it. This is for the examples here I show are for a Debian-based Linux system, but feel free to use your pacman yum package source, ThinkPort, whatever your package manager is. The same thing works on FreeBSD, hardened BSD, OpenBSD as well. So that's nice. You need a certificate authority, which means dealing with PKI and X509 certificates, certificate chains. There's a nice tool, it's called EasyRSA. It should actually be called EasyCA because it not only deals with RSA these days if you get a current version. Yeah, you create a directory, you go into it, you install the package. It creates a bunch of symlinks. You don't actually need to read it. It's just, there's a ton of symlinks and files. It creates them automatically for you, which is convenient. It also sets the modes for those files correctly so that the file permissions are not too permissive, so somebody could steal things. And there's a file, it's called vars for the variables. This is how you control EasyRSA. And you just edit that file and set a few things like the key size, 4096 bits for RSA is fine. It will take a moment for the handshake, but after that, it's cheap. You can set a digest, which means the hashing function used for the certificates. SHA-256 is pretty okay these days. NIST recommends going SHA-384. If you don't trust NIST, go SHA-512. That's just as fine as well. The expiries are for the CA and for the keys. This is 10 years and 1 year. You maybe want to shorten that down sometime before you rotate things. But it's pretty straightforward, actually. We'll be using RSA for the example I show you. But with EasyRSA version 3 and above, you can also use ECC, meaning elliptic curve crypto, which is a lot faster and lighter on the hardware. And it can be used since Android 4, so that's a pretty good thing. Windows Vista, macOS 10.6, which has been since, well, it's been 2008, I think, and iOS 5, it's been ancient, so you're pretty good with ECC these days. Use it if you can, and I recommend going that way, actually. Yeah, then you have the usual fields you put into a certificate. You have a province, a country, a city. Put in whatever you like. You can put your real data into it, yeah, but you don't have to. And that's maybe already done. You simply source that vars file. It sets a few variables in your environment, and you're good. And then you clean that stuff. You use the PKI tool to initialize your certificate authority, and it generates keys. If you go 4096 bits on RSA, you also have to create Diffie-Hellman parameters of the same size. This can take ages. I mean, on a Raspberry Pi, expect a few hours, at least. If you're lucky, it's just 7. If you're unlucky, it may be 20. Don't expect this to go quick, but it's fully automated. Just watch it. And for TLS authenticated traffic, we also need a shared secret. So you must have some way to transfer that shared secret to your clients over a pre-established secure channel. SSH is fine. Going sneakernet with a USB thumb drive, maybe not, because USB, we've heard a talk, might be a risk in itself, but you'll find a secure way to transfer those files and configurations. So you end up with a certificate authority, a bunch of files, certificates, requests, and all that stuff. It's all created for you. It's pretty much automated. And then you create a client for it. If there's something missing, the PKI tool will notify you, and you end up pretty much with a certificate and a key. That's all you need for your CA. So these are the important things. And for the TLS authentication, you also get a TA key file. It's called that way. We'll use it. It makes our traffic more secure and authenticates it. So then you create a server config. Since the OpenVPN package you install on your operating system is client and server, it's the same software. And the bad thing about this is it doesn't install sample config files for a server, as you're probably used to with other daemons like Nginx, for example. So you have to create them yourselves, but that's not that hard. You open this server.conf file, you put in a few lines like the CA points to a file, the certificate points to a file, the key points. It's like parameter, file name, parameter, file name. It's easy. You can find this all over the internet. Then you need to configure the so-called tunnel network. This is the IP range that is used to tunnel traffic between the client and the server. It's a private piece of network, so you use a 192.186 range or 10/8 or 172/12 network, one of those RFC 1918 networks. And it can be pretty small, like a /29 or even a /30 should work. You don't need many IPs there. You push some routing information to the client. So the OpenVPN client that connects to knows where to find the local network it wants to connect to. And you also must include the route to this tunnel network. So there's two lines, one for the tunneling network, the IP range you just choose by yourself. It has to be distinguished from the network you want to connect to. And the other one is 2 lines. It's pretty simple. And you can also tell it to redirect its default gateway so it does not leak traffic to the local network of the client, which means if you want to be connected to both networks, don't do this. Otherwise, people will complain they can't reach their own printer on their own home network anymore because the client is told to route everything outside, and now you have still print jobs. And you can also move the DNS traffic over the VPN so you don't connect leak DNS requests to your local network anymore. These two are a nice example there. The free resolvers provided by the Chaos Computer Club in Germany and the Verein Digital Courage. They offer free DNS resolvers that don't track and don't do any statistics on them. Yeah. One weird thing, these TLS authentication pretty much provides HMAC protection integrity for your traffic. It's funnily, the OpenVPN people call this HMAC firewall. There's no firewall in there. It's just signatures. And once you're done, you can go to the crypto config, which is where pretty much every tutorial you find on the internet to set up OpenVPN ends. It's like, okay, I made it connect, I'm done. But this is where the problems start usually. You have a symmetric cipher, you have an authentication, you have a TLS cipher and a TLS version that you can configure, and you must configure because OpenVPN still defaults to Blowfish and really, really ancient stuff you never want to use anymore. So as for ciphers, you can ask OpenVPN which ciphers it supports. This depends on the crypto library, usually OpenSSL. Go with whatever current thing you find. AES GCM is pretty fine. It's hardware accelerated on almost any platform, so that's good performance. Authentication SHA-512, it's usually accelerated as well these days. Works pretty well. As for the TLS cipher, you might not be familiar with this writing because it's TLS ECDHE with AES. That's the actual IANA names, the standardized names for TLS cipher suites. Most people are used to the OpenSSL notation, which is a little different. They're easily one-to-one convertible. There's tables on the internet where you can find how these work. And yeah, if both your clients are 2.4 and up, which means 243 being current, you can also require TLS 1.2, which you absolutely should if you don't absolutely have to support old clients. Yeah, if you don't know which ciphers your OpenVPN does support, ask it. OpenVPN, show ciphers, and it will spew a long list of ciphers at you. There's AES GCM is a good strong cipher you can use, and the current ones also allow elliptic curves, and you can ask it which curves do you support. There's also a ton of them. If you absolutely want to avoid NIST curves, there's Koplitz curves and other ones available that work fine. OpenVPN can also compress the traffic, which will give you a little more performance on most cases. It might actually adversely affect your traffic throughput on some small boxes which are CPU bound. Test this. You can just turn it on and off. See if compression actually gives you more performance and more throughput, or if it doesn't. This is something that depends on your individual server and client hardware, software stack. It's easy to test, it's just one parameter. And since we like our software to run without any privileges, like the old Unix principle, least privileges to make my job, yeah, make it go, drop privileges to user and group nobody. It's just passing packets. There's no need to write to the file system or something. That's fine. Then you just give it a kick and restart. It will load in the new config, and the server's running, so that should be fine. Don't forget to open the ports on your firewall, or you'll be in trouble, but that's a common thing to overlook. Standard port is 1194 on UDP, unless you have configured it otherwise. So what clients can I use to connect? Well, of course, there's OpenVPN on the command line if you want to. Depending on your distro, it's called OpenVPN, OpenVPN2, OVPN, OVPN2. You'll find it on your operating system. It's available pretty much everywhere. Macs, Linux, BSD, there's no problem with that. On Linux, there's also a GUI for the network manager available. On Mac, you can use Viscosity, which is a commercial product for OpenVPNs. It's $9, I think, works really well. And it can import pre-made packages for configurations, which is very convenient because some firewall appliances actually can export these things. So you just get a zip file, drop it on there, and everything's done. And there's Tunnelblick. It's an open source OpenVPN client for the Mac. It has a user interface. It's not that pretty, but it also works. And they're really good with updating to new versions of OpenVPN. They're very closely following that. On iOS, if you have an iPhone, since iOS 6, you get the official OpenVPN Connect application. You can use that. If you're using Android, there's OpenVPN Connect and OpenVPN for Android. They're both available on the Play Store and F-Droid, so that's nice. They're both free. And there's even a client for Windows. It does not run on Windows XP, though the icon really looks like it would. Yeah, it's not that pretty. If you're on Windows and configure that stuff, OpenVPN, yeah, don't be scared. This is Windows screenshots. I did not make them. I got a friend who did this for me. It pretty much hides in your taskbar with a tiny icon that does not speak a lot. You need a configuration at the certificates, which you got from your server. You configured it there. You put this data in, and it should be connecting. There's not a lot of whistles it does. It just connects with a tiny green icon. If you need to configure it manually, might happen. There's these ugly lines for a config file for Windows. Give it a server name, and all the certificate stuff you already configured on the server, you can pretty much copy paste these lines back and forth. They're identical. There's a single difference to those. You've all seen that already. It's identical. Just copy paste them over. And yeah, when you're connected, the right-hand corner is the icon. It's a tiny monitor with a lock on it, and it's green. Why ever they chose it, but you're connected. That's nice. So works on Windows. If you want to get a GUI for Network Manager on Linux, that's fine as well. It's called Network Manager OpenVPN. Looks okay. You can click your configuration there instead of typing it. But the fields, they all have the same names. You'll pretty much be familiar if you have done this on the server. You can configure this. It's easy. There's a checkbox for the data compression and for the cipher modes and hash functions. This one shows CBC. Please don't use CBC mode. Go something with GCM. That's better. And there's the TLS authentication. There's the key file, the TA key. That's just a file you get. And there's the key direction. That's a funny parameter. It's either 0 or 1. And if you put a 0 on the server, you have to put a 1 on the client, or otherwise. It doesn't matter which way. They just have to be different. Just because. But you can easily trip over by everything's the same. I copy paste on, and it doesn't work. So that's one thing to keep an eye on. And yeah, you connect, and it works. On the Mac, it's easy with viscosity. It has a nice thing. There's a plus in the lower left-hand corner. You click it. You drag the config file in there. It says, well, your connection has been imported. OK. It connects. Yeah, that's it. Screen. Done. Also gives you a nice, shiny throughput graph, how the VPN is behaving. TunnelBlick, it has a plus button in the lower left-hand corner. No, that does not work. I said it has a GUI. You have to drag and drop the files there. I don't know why, but it connects as well. It has these floating windows where it shows you the shining light at the end of the tunnel when it connects. That's fine. Some troubleshooting tips. You probably have varying throughput or packet loss at some times. This is usually connected to MTU problems with OpenVPN. It seems to be that common that they actually put a MTU test feature into OpenVPN. It's called MTU test. You put that in the config file and restart the server, and it will give you, after about 3 minutes, it will give you a report. So if everything's fine, this is a good connection example. So it will say, well, I'm connected. That's okay. I'll use this one. And if it's not, you'll get something like this. And it will even suggest a size to change. So in OpenVPN, you can change the fragment size and the MSS fix together. They just differ by 40 bits, and you add a line to your config, and now you have a stable OpenVPN. So that should help you troubleshoot if you have some DSL connections. They usually shave off a few bytes of your packets, and this helps to make it stable and get a better performance. So OpenVPN, we're pretty much done with it. Yes, you'll get the slides for all the stuff. And we've reached the middle of the talk, which is nice. Anyone know the reference? Yeah. For certain definitions of middle, of course. Yeah. Let's look into IPsec and IKv2. IPsec usually scares the shit out of every sysadmin. We know, yeah, it works, it's good, but I never touched it. Yeah, me too. You can use it. Some people actually thought, okay, this must be easier for users to use because it's a good technology. So they created AlgoVPN. This came out of their own needs. Small company in a startup in the United States, they require to have VPNs because they don't have an office space. They pretty much travel all the time. So they need a VPN to route their traffic, and they don't run their own servers. So they just click some cloud instance on a provider and want to use it there. But setting up a cloud instance just for an afternoon is incredibly stupid because it's a lot of work. So they said, well, we can script this. And so they started scripting things. And what they came up with is now an open source project on GitHub. The organization is called Trail of Bits, and the product is Algo VPN. It's Algo. It's basically a bunch of Ansible playbooks, shell scripts, and a lot of magic that set these things up for you. So what Algo VPN can do, and the features are, it uses IPsec and only IQv2. That's a good thing. It only supports pretty much in the high security mode and single cipher, which is ASGCM, Galois counter mode. It uses SHA-2 as the HMAC and nothing else, no SHA-1 or MD5 or other broken things. And it uses the standard Prime 256 elliptic curve crypto for Diffie-Hellman. It can create profiles, installation profiles for Macs and iOS, just like all the config is in a file that you put on the client. It provides all the helper scripts you need to add and remove user accounts. So if you want to have like new users to use your own VPN server because you share it, there's scripts to just add new users there or kick out other ones you don't like anymore. It can even be used as an HTTP proxy to do ad blocking for you. I personally would not use that. Just get a good ad blocker on your browser and do it there. So I'll ignore that one. And it's based on Strong Swan, which is an open source BSD licensed implementation of IPsec and IQv2. What Algo VPN is not, the anti-features, it doesn't use any outdated or insecure ciphers, which is a great thing, like L2TP or IQv1 or something, such a thing. It doesn't install Tor or OpenVPN or any other daemons. It does not depend on TLS. It does not depend on OpenSSL. We all remember the famous Heartbleed things and other security problems with OpenSSL. So not having to use that gives some peace of mind. It does not use any extra installed clients on most operating systems, so there's no need for third-party software. It's just working out of the box. And it does not claim to provide you with anonymity or to be censorship resistant. It can't be. No VPN can be fully censorship resistant or provide anonymity. It doesn't claim to do that. That's nice. And it also doesn't claim to protect you from the FSB, the NSA, the KGB, or the FSM. So what do you need to get this Algo VPN thing? Because it sounds interesting, doesn't it? They officially support Ubuntu Server 1604 long-time service. That's okay. It just as fine works on 17. With a little love, you can make it run on Debian, plain Debian Stretch as well, and also on Armbian with a Raspberry Pi. You might have to tweak some of the lines a little, but that's something that's reasonably easy to find, because if you start it, it will log an error, and that's what you fix. Not officially supported, but it works with some handwork, is FreeBSD and hardened BSD. You can make it run on those. And of course, you can run it on your own Metal, or you get a cheap virtual machine instance. You can just click some Amazon, Microsoft, Google, or DigitalOcean VM for $5 and have a machine that will really be happily running Algo VPN. For this one, this is a hard one now. I show you a real-time full installation of the Algo VPN server. You can either run the software, the installation software on your laptop and have it remotely configure a cloud instance or your own remote server, or you just copy this, download the scripts on the remote, on the VPN server itself and just run it locally on that machine. This is what I'll be showing you. This is a recorded video, but it's in real time, it's playback, it's all pretty much a recorded shell session. So I'll try to do some commentation on this one. So we'll start with the shell. We'll look into it. The prerequisites are documented. It's just a bunch of packages. You just copy that line to your shell. You start installing these packages according to the documentation. Sadly, the documentation is missing one dependency. which will be needed just a moment later. Yeah, Austrian internet connections are usually slow, so this takes a moment. Once the packages are done, you fix that missing dependency. We're now, I think, 20 seconds in, 30 seconds, something like that. Installs a bunch of Python things because that is needed for the Ansible playbooks afterwards. It's missing the zip dependency, so you install zip to unzip it. There's zip. I'll clear the screen. Just get the master project from GitHub. You download it. It comes as a zip, so that's why you need zip to unzip it. We're done. You change directory into the Algo VPN master. Let's look at it. There's documentation. There's a bunch of files. Requirements.txt, which means it's a Python project. We create a virtual environment project. We activate that project, install pip into that Python project, and from the requirements.txt file, like any good Python project, you just get all the packages for pip and Python you need. There's a bunch of OpenSSL connections and all the API plugins that you need for Google, Amazon, Microsoft, and DigitalOcean VPNs, virtual machines that you can buy. A good metric ton of crypto plugins for Python. They take a moment. These are a little bit larger things that you need. And once these are done, that's all you need to install. There's a config file. You add the user accounts you want to do. We showed this off in Vienna at the Linux Wochen, Linux weeks. You put in the username. Well, maybe let's add one more. You save that file, and you start the Algo VPN playbook script as root, of course. Yes, number 5, I want to install this on this Ubuntu server. It's easy. You add the IP address of the server, the public IP address of the server. No, I have not deployed this previously, and I want to use iOS clients and make them automatically connect. I do not want to do any DNS or SSH or proxy stuff. Yes, I want to support Windows and Linux clients as well with this. And then the Ansible magic starts. It's pretty much going there, configuring your IP stack, your firewall, the required ports to open on the firewall. It does some syscontrol stuff to tweak your IP stack, configures IP stack, configures the DNS things, the certificate chain, so it creates a certificate authority, it creates the client certificates. Every client gets their own pair of keys, their own certificates, so there's no sharing of anything between clients, and this is it. Your VPN server is already running. So that's really nice, and this is a VM instance with a single, I think, 1.7 or 2 gigahertz core and a 1 gigabyte RAM, and it's way overpowered for that. On the Raspberry Pi, this process just runs through like that, and it takes about 14 minutes on a Raspberry Pi 3, so that's really reasonable to use. Yeah. There's the CA key password you see there. This one is protects the private key of your certificate authority if you want to add users at a later point. You can instruct the Algo VPN script to actually drop that key immediately and never show it to you. Of course, then you never can add any users later. But if you just fire up an instance for an afternoon and you know I'll just delete it afterwards, then this is a pretty secure thing to do because nobody else can break into the machine and add other users because they're lacking the private key to actually create new certificates and sign those things. So that's a good idea. If you want to reuse that over a longer time, keep track of these data that is shown to you. So, sounds reasonable to do. Clients, of course, we have a server, we want to have some clients that can connect to. On Linux and BSD, that is supported. macOS and iOS 8 work out of the box. On older iOS Android clients, 4.03, there's a Strong Swan client on the Play Store. I have not found this one on F-Droid. It might come up there, or even be there already. I don't know how about what about the recent versions of Android, like 7 and 8, if they already support IPsec out of the box. I'm not an Android user, so if you know this, please help me out. That would be interesting. And even Windows 10 works, just out of the box. Everything's already there, nothing to install. Just need to configure it with the client. If you have a Mac, that's easy. You get a pre-made mobile config file. Everything you need to configure this VPN on the Mac is in that file. You just literally double-click it. The system says, oh, well, you have a configuration profile. That is handy. It installs a VPN service and 2 certificates. Do you want to look at it? Like, show me this profile, or you want to continue? Yeah, I want to install this. Okay, it's like spinning for a few seconds, requires an admin password. And by the time it shows you that it has already all done this, it's already connected. This literally takes 5 seconds on just any Mac. You can tell it to automatically connect. So as soon as you have an internet connection, it will connect this IPsec tunnel for you. If you don't want to do this, you can just tick off that box that says connect on demand, and you can manually connect and disconnect as you like. And it's even intelligent enough to distinguish between the local network where your file server and printer are and internet traffic, so it doesn't tunnel your local network through because it doesn't make sense. So that's really easy. On iOS, it's similarly complex. You have the same mobile config file you use on a Mac. You can just put on an iPhone. You open it, it says, oh, it's an installation profile. How nice of you. Do you want to install this? So, no, I'd like to look at it. You can inspect all the stuff. Of course, you enter your passcode from your phone. You get a nice lecture of, okay, I will install a certificate for a VPN server. It will be added to the list of trusted certificates on this device, and it can only be used to sign VPN connections. So this certificate cannot be used to intercept TLS, HTTPS, or email traffic, which is a very, very good thing. So this cannot be used against you, because the iOS will just say, well, this certificate is not valid for HTTPS, I'll refuse it. That's a good thing. And you say, okay, install. And it installed the VPN settings, 2 certificates, and yep, I can connect. List of VPNs, there might be other VPNs you also have, and there's also this connect on demand thing for iOS, so you can manually connect, you can have it auto-connect, you can tell it to connect only when you're on a GSM network, like LTE or 3G or whatever, and not on Wi-Fi. And you can even tell it to connect on GSM and Wi-Fi, except on your home Wi-Fi, because then VPNing usually is not what you want. These are just 3 parameters you can set in the VPN, in the Algo VPN script when you install it, and you can recreate this profile and update it as you like. And yeah, you just check what is my IP on the internet, and you should see the IP address of your VPN server instance. It's running the same immediately. I'm really sorry I don't have the screenshots for Windows and Linux installation. I did not have boxes available to do this in time. I'm really sorry for that. But I know this really works, and it's similarly complex as the examples I've already shown. I can really recommend this. I'm a Mac and iPhone user. I've been running Algo VPN for some time now with Connect all the time on GSM, so my mobile phone carrier cannot spy on me and try to inject traffic and tracking cookies into unencrypted websites. And it's surprisingly easy on the battery, so it does not drain your battery like crazy. You can just let it run. When the connection drops, the VPN tries to reconnect as soon as there's an internet connection back again. So this really works really well. Yeah, that's pretty much it for the Algo VPN. And if you can't use those, or if you don't want to use those 2 solutions I've showed you, there's of course other ways you can get something like a VPN, meaning some layer 2 traffic routing. You can do strange things with SSH. SSH can actually be used as a layer 2 VPN. It's pretty much a site-to-site VPN you can realize that way, meaning you can bridge to remote networks over an SSH tunnel. and this actually has been available since OpenSSH 5.6, so that's available for quite some time. I know nobody actually uses this because nobody knows about it, and it's not that you do? Awesome. Now I know one person who does this. Yeah. And of course there's the good old S-Shuttle. It's like a poor person's VPN you can use, just need an SSH server, or the really cheap version SSH-D, which gives you a SOCKS proxy on your SSH client, and you just point the operating system or Firefox to use that SOCKS proxy, and it will tunnel through your SSH. That's also easy and handy if you don't have any of the other options available. Yeah, this is the end. I'm open for questions.
So one question about IPv6. I haven't seen anything on IPv6, and this is normally dangerous to not leak out anything. Especially on Algo VM.
Yeah,
VPN.
IPv6, if your operating system IP stack does support IPv6, you can also use it with OpenVPN and IPsec. On IPsec, I do have a little more trust in not leaking stuff. On OpenVPN, I really recommend getting out your Wireshark and checking. The same goes for DNS traffic. I'd rather really verify that DNS does not leak. That is usually the common problem happening with these things. So I know it's not a really happy answer, but
about the Algo VPN, have you tried to run it on v6? Because on the GitHub it does have some things about VPN that they're working around it, but the actual front page says nothing.
The instance I've installed there does v4 only because the cloud provider I use there does v4 only. It's a sad thing. And in Austria it's pretty impossible to get v6, so I could not really try v6 yet. It's terrible, I know. I'm sorry.
Hi. To use SSH as a VPN, you have to have a root access on the destination server. Is there any workaround? Because someone has to create the tunnel device on the server, right?
Yeah, you either have your operating system use auto SSH to just re-establish the tunnel, or you do it manually.
Yeah, but I have to be root on the server, right? To create the tunnel device.
I think so, yes.
Is there a workaround?
None that I know of, but that only means that I don't know any workaround. That doesn't mean there is one.
I have another question, if you're up to. Is there any way on Android devices, when the VPN connection is dropped, then the Android device will fall back to the wireless network that you are already logged in? Is there a workaround not to connect to the internet if the VPN connection is dropped?
I don't know about Android. I don't use it. I don't have any Android devices, so I have to refer you to the community to help you out on that one. On iOS, there's certainly no way to prevent that because iOS will immediately try to connect to the push notification servers all the time. And you can abuse this feature of iOS to trigger a VPN connection. So as soon as it wants to connect to because the push notification servers on the Apple side are known, you can, if the iOS wants to connect to these, trigger a VPN connection. That's something iOS can do. And you can abuse this functionality to force it to try doing the VPN thing. There are other ways to ensure that your traffic is tunneled on iOS. They sometimes even require to have a separate APN from your mobile phone carrier. So that's more thing you can get as a company than a private individual.
And I have a tip for the community regarding DNS leaks. I use DNS script to another VPS server, so I am encrypting my DNS queries. Yeah,
using DNS script was a tip to prevent or help with DNS leaks. That of course requires that your DNS resolver also supports DNS script, and I have no idea if you could support that on mobile phones, for example. I just don't. I certainly can't do this on iOS. Might be on Android. You're a little more free to tinker with the systems there, but I think it's certainly something to work on and not easily just tick a box and it works. But it's a good idea for the laptop. Yeah. Any further questions? Anyone want to try this on their own box? Yeah. Okay. Great. Awesome. Well, if there are no further questions, thanks for your time.